All right, let's get straight into it. Welcome to a super quick revision explainer for your GCSE chemistry exam. We're going to tackle a really important bit of the quantitative chemistry topic. That's AQA section 4.3.3, yield and atom economy. Okay, let's dive in.
So, just imagine this for a second. You've got a recipe that says it makes 12 cookies. You follow all the instructions perfectly, but when you pull them out of the oven, you've only got 10. Maybe a bit of the dough got stuck in the bowl or one got a little bit burnt. Well, believe it or not, the exact same thing happens in a chemistry lab. Just because your math says you should make a certain amount of something, it doesn't mean you always will.
And this is where two really important terms come into play. First, you've got the theoretical yield. That's your plan. It's the absolute maximum amount of product you could possibly make if everything went perfectly. That's your 12 perfect cookies. But then, you've got the actual yield, and that's the reality. It's the amount you actually walk away with from your experiment, your 10 cookies. So, a big part of chemistry is understanding that gap between the plan and the reality.
So, why isn't it ever perfect? Why don't we always get 100% of what we expect? Well, chemists, of course, have a way to measure this difference, and it's something called percentage yield.
Percentage yield is basically how we score the efficiency of a reaction. It's a really simple comparison. How much did we actually get versus how much could we have gotten if the world was perfect? It gives us a score, a percentage, that tells us how successful our reaction really was in practice. Now, this is a classic exam question, so listen up. Your yield is pretty much always going to be less than 100%, and the AQA spec gives three main reasons why. First, the reaction could be reversible. That means as you're making your products, some of them are turning right back into reactants again. Second, you just physically lose some of it. It gets stuck to the beaker, or you spill a bit when you're filtering it. It's like that cookie dough left in the bowl. And third, your reactants can go rogue and have other unexpected side reactions, making stuff you didn't even want.
Okay, so we get the what and the why. Now for the bit you'll definitely see on your exam paper, the calculation itself. And here it is. This is the formula you've just got to burn into your brain. Percentage yield is the actual mass, the stuff you really made, divided by the theoretical mass, the stuff you could have made, and then you multiply that by 100 to get a percentage. It's pretty straightforward as long as you get the numbers in the right places.
Let's do a quick one together, shall we? So, say your calculations told you that, in a perfect world, you should make 50 grams of product. That's your theoretical yield. But you finish the experiment, you weigh your product, and you've only got 45 grams. That's your actual yield. So you just pop those numbers in the formula. 45 divided by 50 times 100, and that gives you a percentage yield of 90%. Simple as that.
But wait a minute, a high yield isn't the whole story, is it? I mean, what if you have a 90% yield, but the reaction itself creates a huge amount of useless, wasteful junk as a byproduct? That doesn't sound very smart. And this is where our second big idea comes in, a different way to measure how good a reaction is.
Meet atom economy. Now, this isn't about how much product you manage to collect at the end. This is about how much of the stuff you put in at the start, all those atoms in your reactants, actually end up in the useful product you wanted to make. In other words, it tells you how wasteful a reaction is by its very design. Let's think about it like this. Imagine all the atoms you start with are the ingredients for making a donut. Atom economy asks, what percentage of those ingredients actually end up in the delicious donut, our desired product? And what percentage ends up as useless crumbs and offcuts that just get thrown away? A reaction with a high atom economy gives you more donut and less waste.
And you guessed it, there's a formula for this one too. To work out the atom economy, you take the relative formula mass, that's the MR, of the one product you want, and you divide it by the total MR of all the reactants you started with. Then, just like before, you multiply by 100 to get your percentage. A really high atom economy means hardly any of your starting atoms were wasted.
Right, this is probably the most important bit to get your head around, because a lot of students get these two mixed up. They measure two totally different things, so let's put them right next to each other and see the difference. Let's boil it down. Percentage yield is all about your practical skill in the lab. It's about efficiency and how much product you manage to collect without spilling it or losing it. Atom economy is about how clever the reaction is on paper, before you even start. It's about wastefulness and sustainability. You want 100% for both, of course, but one is about not being clumsy, and the other is about choosing a smart, non-wasteful chemical path in the first place.
And this isn't just some random concept I'm throwing at you. The exam board AQA literally says in the specification that high atom economy is super important for sustainable development and for economic reasons. And that makes sense, right? If you use reactions that make less waste, you're saving money on raw materials, you're using fewer of the planet's resources, and you're not producing as much pollution. That's why this matters so much.
Right then, let's wrap this up and put these two powerful ideas into your exam revision toolkit ready to go.
So here's the cheat sheet, the stuff you absolutely have to remember. Percentage yield is all about the practical result. What did you actually make? The formula is actual over theoretical times 100. Atom economy is all about the design of the reaction. How much of your starting stuff became useful stuff? And the formula is MR of the desired product over the total MR of all the reactants times 100. Nail those two and you're golden.
And I'm going to leave you with a final thought to chew on. Imagine you're running a big chemical company. Which reaction is better? One that's really efficient in practice, you get 95% of what you expect, but it's an incredibly wasteful reaction by design, or a reaction that's a bit messy. You only get a 60% yield, but in theory, it creates almost zero waste. That's the kind of question that green chemistry is all about. Good luck with your revision.